Suppose we have an array of n numbers, and we want to write a function that rotates it to the left by k. If k is 3, this would shift these 3 elements to the end of the array. This is trivial if we can create a new array, as we simply copy the rotated subarray to the end and place the remaining subarray at the beginning, which we can do as follows. However, since we created a new array, this approach has an extra space complexity, also known as auxiliary space complexity, of big O of n. Can we do this without creating the new array, and instead by shifting elements within the original array? In other words, can we do this in place? This would have a constant extra space complexity. One of the most well-known in-place algorithms is used to reverse an array, and it does this by creating a pointer at the left, a pointer at the right, swapping the elements being pointed to, moving them in, and then repeating until the pointers converge or cross over. Well, it turns out you can express rotation as a series of reversals. In order to see it, let's visualize the array as a triangle. Now, let's create a copy of the triangle with the desired outcome, which is to rotate this subarray. Now we try applying reversals that will get us there. If you reverse the entire array, you see that we have the desired output, just with each individual segment flipped. So, all that remains is to reverse each subarray. In summary, to rotate an array by k, you first reverse the first k elements, then you reverse the remaining elements, and then you reverse the whole array. As a follow-up, consider the following. How would you modify this algorithm so that it also works with negative k, which we'll interpret as rotations to the right? Also, there is another in-place solution to this problem with a completely different pattern of shifting elements around. See if you can come up with it.